Hi grade 8, Assalamu alaikum. Welcome back to the physics classroom. Today we are going to solve the exercises on page 110, 111 of the textbook. Exercise 6. The frequency of a vibrator is 100 Hz. Calculate its period. We recall that the period of a vibrator is 1 divided by the frequency. In this case, it's 1 divided by 100, which is 0.01 seconds. What is the period of a vibrator whose frequency is 1/3 of that of A? Here we don't have to calculate, we just have to remember that the frequency and the period are inversely proportional. So we could say that when the frequency is 3 times less, the period will be 3 times more. So it will be 0.03 seconds. Again, we say this since the frequency and the period are inversely proportional to each other. Exercise 7. A source of waves makes 10 vibrations in 2 seconds. Calculate its frequency and its period. So the frequency is the number of vibrations divided by the time. Again, the time has to be in seconds, and in this case it already is. So we say it is 10 divided by 2, which is 5 Hz. The period, as we've said earlier, is 1 divided by the frequency. And in this case, we use the frequency we have just calculated. So we say 1 divided by 5. And the answer here is 0.2 seconds. So if the wave covers 20 meters in 4 seconds in the same medium, calculate its speed of propagation. Again, we need to recall that the speed of propagation is the distance divided by the time. In this case, it's equal to 20 meters divided by 4 seconds, and our speed of propagation is 5 meters per second. Calculate the distance covered by the wave during one period. So we have to consider one period being 0.2 seconds. Again, we go back to the formula that we have taken earlier, which is speed is equal to distance divided by the time. So in this case, we need to calculate the distance, which is equal to the speed times the time. So here, distance equals speed times the period, which is the time, equal to 5 times 0.2, which is equal to 1 meter. Note that this is the wavelength. Exercise 8. Halley's Comet describes an elliptical orbit about the Sun. The comet is seen from the Earth in the same position every time it is near the Sun. Knowing that it was seen in 1606, 1682, 1758, 1835, 1910, and 1986. Before we answer the questions about this, let's describe what a comet is. So a comet is a body that orbits around the Sun. It's usually a rock of some kind, and it orbits around the Sun in a certain direction around the Sun. As mentioned in the question, it has an elliptical orbit. What does this mean? Okay, so consider this being the Sun, and this is the Earth going around. Here is an elliptical orbit. An ellipse is a shape that is elongated like an oval. So if it turns like this around the sun, we say it is an elliptical orbit. Now let's answer the questions for exercise 8. Calculate the time between two successive appearances. What do they mean by successive appearances? They mean the two corresponding years, the years that are right after each other, that follow each other. So the first successive appearance was between 1606, the next one was 1682. The time between that is 76 years. The time between 1682 and 1758 is 76 years. Between 1758 and 1835 is 77 years. And between 1835 and 1910 is 75 years. And between 1910 and 1986 is 76 years. So the appearance of Halley's Comet is considered a periodic phenomenon. What is the average value of its period? So an average is always adding all the numbers together and dividing them by how many there are. So the average value is adding these together, 76 plus 76 plus 77 plus 75 plus 76. The answer to that divided by 5, which is 76 years. In what year is or was the next appearance expected? So have we already seen it again, or will we see it soon? So in order to do that, we look at the last year, the final one, 1986, and we add the average to it, which is 76 years. So the next year will be 1986 plus 76 years, and this will be in 2062. Thanks for watching grade 8. See you next time in the physics classroom.